Hay muchos árboles en esta isla. Por ejemplo, el laurel, este es el que más utilizamos para sacar madera de él, porque es un árbol muy fino y la madera en realidad dura bastante y es muy bueno para las obras que estamos haciendo.
Roatán, a small island in the Caribbean Sea, just off the coast of Honduras. It's known for its dense forests and stretches of coastline that remain largely untouched. In recent years, tourism has steadily grown. On one hand, it brings new activity and investment. On the other, it's reshaping parts of the island, with new construction, cleared land, and changes in how certain areas are used. For local artisans and craftspeople, this changing environment means finding new ways to keep their work relevant, balancing long-standing traditions with the realities of a modern, connected world. This is where we find ourselves, at the intersection of traditional craftsmanship, rooted in local materials and knowledge, and the push to integrate new technologies that can meet the demands of the present.
Right, we could argue that the trees just come from across the street in the forest, and right, they were cut down and brought here. The idea of the workshop was to exactly do that, right? So to practice some kind of cool scanning to fabrication workflows on the robot with a kind of very short timeline, right? So designing till the last minute and modifying files as we go, right? Because designs continuously keep evolving and changing, right? So this kind of design to production workflow has also been short-circuited, if you will. And to bring students here and our workforce hand in hand to kind of learn and produce something that is kind of quite exciting and quite complex.
Hello, so I'm Alicia. I'm an architect. I am the founder of the Circular Factory. We started collaborating with IAAC to set up a microfactory on a remote location using minimal footprint and minimal resources. We have been collaborating for 1 year now, looking at using raw materials in a local context, especially with that digital workflows.
Hello, I'm Alexandre Dubord, architect and engineers, and director of the Master in Robotics and Advanced Construction. We had developed a set of tools that train our students to use technologies such as sensors, robotic fabrication, computational design, and many other elements that help you to build an architecture that read or let's say get inspired by the material you're using. So it adapts to the material we could find and therefore adapts to different situations.
So the workshop was about going from scanning trees in the forest and then trying to design with unknown geometries of the trees, and then bring that into the production workflow to detail them, to do the robotic files for them, for fabrication, assemble, etc.
We used the wood from the island, and we tried to mix digital tools with local craftsmen.
So I would say the beauty about the project is that we are actually taking the natural material of the trees as they are and trying to work with them. We would already scan them with drones in the forest to have approximate dimensions of the pieces and knowing their shapes and their sizes, so that actually we kind of can categorize already and cluster which parts we would want to take.
So we used the photogrammetry for scanning, then we created the mesh.
We would have a lot of pictures 360 around the log, and in a photogrammetry software we would then recreate a mesh that fits very close to the physical model.
And then with this digital models of the wood, we could basically do the digital design.
We use techniques like genetic optimizations, where basically you enter a goal, a final goal, and the form will then automatically shift to the most optimized form that we then finally go ahead with to feed it into the fabrication process. We do some tweaks, we add the joints between them to then finally pass on to the final step, which is then the fabrication and the assembly parts.
To manufacture all the parts and components making up the final pavilion, at the circular factory we use 2 robotic arms from ABB mounted on a linear axis, which means essentially that you are able to move the bases of the robots inside within the robotic cell, and this gives you more flexibility in terms of motion. We were also able to work in parallel to have different stations where we mounted the logs and the forks to be manufactured, and that sped up quite a lot the entire manufacturing process. We used a variety of cutting tools, including milling bits and circular saw, to cut the different joints and to perform the different machining operations on the raw material we were working with. I believe the introduction of digital fabrication, especially related to the context of the island, is particularly interesting and important because with such tools you can reinterpret and rethink the tradition carpentry knowledge, which is very common on the island. Digital fabrication also plays a crucial role when it comes to give the possibility to local carpenters to scale up their volume of production and to be able and be competitive on the market for bigger architectural applications, because with digital fabrication you can use the local material which is very eradicated into the vernacular architecture of the island.
I think one of the biggest challenges is to understand the physical material, because when we are designing it with materials digitally, we don't really have the feeling of how they are in the real world. And for me, working with wood, non-standardized wood, that was the biggest challenge, because we really need to understand their physical properties. We need to understand how the machines, like the robots and the end effectors, work with the material, and then having everything in mind while designing digitally, that's a task. And finally, assembling it, because I mean, when you're in the computer, you can just rotate a part and you have no idea how much it weighs. But in real life, you really need cranes to move one piece because it's really heavy. So these 2 things for me were the big challenges at the end.